All right, in this video, we're going to be going over force acceleration. All right, and pretty much all that means is that if you have some sort of object and you apply some sort of force to it, there's going to be a resulting acceleration associated with that force. All right, so the first thing we're going to go over is the difference between weight and mass. All right, they are different. I feel like in everyday life when we use them, we kind of interchange them to kind of mean the same thing, but they actually do have different meanings. So the weight of an object is actually equal to its mass times gravity of whatever location you're at. So obviously if you're on Earth, you're going to weigh more than if you were on the moon. And so your weight is actually dependent on gravity or dependent on your location, whereas your mass is always constant. So now this equation here, this weight equals mass times gravity, this is when an object is at rest on whatever planet you happen to be on. All right, so let's say, for example, if at rest and on Earth, someone weighs 1,000 newtons. What would their mass be? All right, so we're just going to use our equation, W equals mg, and solve for mass, because that's what we're solving for. So we're going to divide both sides by g. So mass equals weight divided by gravity. Our weight is 1,000 newtons, and gravity on Earth is 9.81 meters per second squared. Now, a newton is actually a kilogram times meter per second squared. So you'll see these will cancel out. We'll be left with kilograms. And we will get the mass of this person is 101.9 kilograms, or we can just round that up to about 102 kilograms. All right, so that would be your answer for that one. So go ahead and try this one on your own. If a man weighs 981 newtons on Earth, find the mass. All right, so same type of thing that we just did. Go ahead, pause the video, work it out on your own, and then you can check your answer with the PDF solution found below this video. It'll be number 1 in that PDF. All right, so now let's go ahead and talk about our sum of forces. So a sum of forces on an object is actually equal to mass times acceleration. So if you remember in statics, because nothing was moving, we put this equal to 0 over here. So our sum of forces equals 0. Well, now our sum of forces is going to be equal to mass times acceleration. Now this can be split up into two different directions. So our x components and also our y components. So if you had an object and it had some sort of force on it this way, obviously it would be moving up and over. So you would have some sort of m acceleration in the x direction and m acceleration in the y direction. All right? And that would be equal to your sum of forces on this object, which would be that right there. So F equals MA, all right? And so you can actually draw a free body diagram and then your like acceleration diagram, and then just solve for your unknowns, whatever you're looking for. So for example, if we have some sort of box on a flat horizontal surface, and we're pushing on that box with 500 newtons of force, and this surface here has a coefficient of friction of 0.4, and this box weighs 100 kilograms. Find the horizontal component of acceleration of this box. All right, so again, we're just going to free body diagram this box to start out. So we have our 500 Newton force. We also have 100 kilograms acting down. We'll have a normal force, and then we'll also have our friction force, which is equal to mu times our normal force. Now, all of those forces are going to be equal to mass times acceleration. Now we know that this box, it will be accelerating to the right, so it's going to be max. All right, and then we can just set up equilibrium equations using our diagrams that we just drew. So we'll do sum of forces y first, equals may. We'll have up be positive. So we'll go ahead and do the left side of our equation using this diagram right here. So we'll have minus 100 kilograms. Now we need to get that into a force, so we've got to times that by gravity. And then we also have our normal force. And all of that is equal to m times ay, but you'll see over here, ay we don't have, so this is actually going to be 0. Because ay is 0, so this whole thing goes to 0. So, from this equation, we will get that n equals 981 newtons. All right, now we can go ahead and do our sum of forces y equals mass times, or sum of forces x, equals our mass times acceleration in the x direction. And I'll go ahead and have going to the right be positive. All right, so left side of the equation here, right side of the equation here. All right, so we've got 500 newtons to the right minus our friction force, which is mu 0.4 times n, which we solved for was 981 newtons. And that's equal to our mass times acceleration in the x. We know our mass is 100 kilograms. And that'll be times by acceleration in the x direction. So then we can go ahead and just solve this equation out for acceleration in the x direction. And when you do that, you'll get 1.076 meters per second squared. All right, so go ahead and try one of these on your own. Say you've got, again, some sort of box on a horizontal surface. The box weighs 200 kilograms. And there is a 600 Newton force being applied at a 20-degree angle. And the coefficient of friction equals 0.2. All right, and go ahead and find again that acceleration in the x direction. All right, so go ahead, work that out, and then you can check your solution with the PDF. And it'll be number 2. All right, and that's pretty much all we have for force acceleration.